Hello everyone, welcome back to my channel. Today's topic is IoT physical device and endpoint. Yes, introduction to IoT physical devices. Definition: IoT physical devices are the hardware components that interact with the physical world, collecting data and performing action. Example: sensor, precursor, wearable, and industrial devices. Importance: they form the foundation of IoT system, enabling data collecting, processing, and control. Role of endpoint in IoT. Definition: endpoint are the devices or nodes that connect IoT devices to the network, enabling data transmission and communication. Functions: collecting data from the physical devices, processing data locally or in the cloud, and facilitating communication between devices. Types: edge devices, gateway, cloud, endpoint, and wearable devices. Types of IoT endpoints: edge devices, devices located close to the data source; wearable devices, small lightweight devices worn by users such as smartwatches or fitness tracker capable of collecting and transmitting personal health data. Gateways, intermediate devices that aggregate data from the multiple endpoints performing protocol translation and data filtering. Cloud endpoints, servers are virtual machines. Servers are virtual machines in the cloud that receive, process, and store data from IoT devices. Wearable device, small lightweight device worn by users such as smartwatches and fitness tracker, um, capable of collecting and transmitting the personal health data. Industrial device, specialized device used in industrial settings such as sensors for monitoring and machinery or actuators for controlling process. Role of endpoints in IoT ecosystem: data collection. Endpoint gather data from sensor, actuators, and other physical devices in the environment. Data processing, they perform local process tasks such as data aggregation, filtering, or analysis before transmitting the processed data to the cloud or other endpoints. Connectivity endpoints facilitates communication between the various IoT devices, ensuring seamless data exchanges with the IoT ecosystem. Decision making process data locally endpoint. Real-time decision making capabilities, reducing latency and improving responsiveness in IoT applications. Characteristics of IoT endpoints. Connectivity options: endpoints utilizes various component communication protocols such as Wi-Fi, Bluetooth, uh, Zigbee, LoRaWAN, etc. Depending on the application requirement, power requirement, endpoint may be battery power, means power impacting their operational lifespan and maintenance needs. Processing capabilities, endpoints range from simple microcontrollers to the powerful microprocessor, influencing their ability to handle the data processing tasks. Security future endpoint implementing encryption, authentication, and other security measures to protect data integrity, and prevent unauthorized access. Challenges in IoT endpoints: limited resource. Limited resources endpoints often have constraints in processing power, memory, and storage, which can cause challenge in handling large volume of data. Security vulnerabilities: endpoints are susceptible to cyber threats and attacks due to their connection to the internet, requiring a robust security measures of safeguard sensitive data. Interoperability issues, ensuring compatibility and seamless communication between different endpoints and IoT platform can be challenging, especially in the heterogeneous environment. Scalability. concern. Scaling IoT deployments to accommodate a growing number of endpoints while maintaining a performance and reliability for logistical and operational challenges. Best practices for IoT endpoints development. Priority security. Implement end-to-end encryption, secure boot mechanism, and regular security updates to mitigate potential vulnerabilities. Designed for scalability, detection solution that can easily scale to accommodate a growing number of endpoints and handle increasing data volumes. Optimize power consumption, employs power efficient hardware components and uh, software algorithm to prolong battery life and reduce energy consumption. Implement over the air updates, enable remove firmware update to ensure the endpoints are always running the latest software patches and security fixes. Case study: smart home devices. Example of IoT endpoints in a residential setting. Device including smart thermostat, security cameras, door locks, and smart light systems. Endpoints communication with each other and with the center hub and cloud server to provide a remote monitoring and control the automation functionalities for homeowners. Case study: industrial IoT. Example of IoT endpoints in industrial setting. Device includes sensors for monitoring equipment condition, computers for controlling machinery, and industrial robots. Endpoints enable real-time data collections, enables the decision making to optimize the production process, improve efficiency, and reduce downtime. Future trends in IoT endpoints, edge AI integration, increasing adoption of edge computing and AI capabilities at the endpoint level for real-time data processing and decision making. 5G integration leveraging the high-speed, low-latency connectivity of 5G network to enhance communication and enable a new IoT application expansion into a new industrial continued expansion of IoT ecosystem into sectors such as healthcare, agriculture, transportation, and smart cities, driving innovation and digital transformation. Conclusion: IoT physical device and endpoint server has the backbone of IoT connectivity, enabling data collection, processing, and communication. Emphasizes the importance of understanding the types, roles, and characteristics of IoT endpoints in building robots and scalable of IoT solutions. Highlights the challenges, best practices, and case studies discussed to provide insight into effectively developing IoT endpoints. Acknowledge the future trends shaping the evolution of IoT endpoints such as Edge AI integration, 5G adoption, and expansion of into new industries.